Hi, I'm Oliver, age 24. Today, I don't have a script. I'm just gonna wing it, and I'm gonna talk to you about singletons. And I'm gonna hope that it comes out intelligibly so that I can cut it up into a video that makes sense. I'm hopefully gonna talk to you about what a singleton is, when to use a singleton, why they're a little bit spicy and a little bit controversial, and then I'll share with you an ultimate singleton script that I've been working on that you can just import into your project, and then you can use it to make your own singletons without having to code them each time. Firstly, what is a singleton? Well, to understand that, we need to take a look at what scripts do and how they work in Unity. So essentially, you'll write a script and then you can put that script onto as many different game objects as you like. So if you think about it, you have the script and then you have instances of the script in your project. And I think that's the bit you need to kind of wrap your head around, is the script itself isn't the scripts that are in the project. The scripts in the project are a copy or an instance of the script that you've written. Maybe another way of explaining it, if you draw a picture, then you sell prints of that picture. Those prints are not the actual picture, but they are prints of the picture. Now, I'm not sure that is the best way to explain it, but I feel like it leads into it quite well. So once you understand that the scripts that are on objects are instances of that script, you kind of understand how you can refer to other scripts. So for another example, if you've got a player and an enemy, and the player has a player manager script and the enemy has an enemy manager script, maybe when the player attacks the enemy, you fire a message to the enemy manager and say, "I have attacked you." And in that case, you're sending a message to that specific instance of the enemy manager. This is useful because if you have 100 enemies in your scene and each one of them has an enemy manager script, you want to be able to refer to specific enemy managers. You don't just want to call enemy manager and it hit all of those scripts as if they're the same thing. You want one specific version of that enemy manager, the one that is on the specific enemy that you are targeting. So each script exists once, and then each instance of a script can exist as many times as you like. Okay, and if that sort of makes sense, then a singleton is when we want specifically to go against what I've just said, and we want to have one copy of a script, and we want to be able to reference that one copy anywhere else in the game. So you might be wondering, when do you need one copy of something in your project? And good examples of this could be your game manager. You only want one of those, or your music manager, or your sound manager, or a script that handles which scene to load, or maybe your saving and loading system you want to have as a singleton. And all of those things make sense to only exist once in your scene, because you don't want to have two music managers so that in your game, when you're trying to trigger different songs to play, you have two songs playing at once. You would presumably only ever want one song to be playing at once, and you want the music manager to handle that. And in fact, if you had two songs playing at once, you'd probably still want one music manager to handle that situation. And then with the game manager, maybe your game manager handles which scene to load next, when to save the game, when to quit the game. And really, you only need one of them to control that. And if you had two, they'd sort of be competing for which one has control and which one you are referencing from other scripts. So that brings us to a singleton. So a singleton is a way to force the game to only have one copy of a script. And if you only have one copy of a script, you can put a reference to that copy within the script itself, which is quite cool. So for example, with the game manager situation, you could have the game manager script that you've written, and then an instance of the game manager, and then in the game manager script itself you have a reference to the instance of the game manager. And then that means anywhere else in your game you can just write game manager.instance and you've instantly got a reference to the game manager. You don't have to do get component game manager or find within scene game manager, and you don't have to drag it in the inspector so that you have a reference to it. So if that makes sense and you're following me so far, you're probably thinking, wow, that sounds really useful and amazing. And honestly, it is. It's really cool, it's really powerful, and once you've discovered them and you can use them, you will want to use them all over your game. And that brings us to the controversial, spicy opinions about singletons. I guess the main complaint against them is that with great power comes great responsibility, and if you use them everywhere in your project, you can turn it into a big spaghetti mess. The other issue I've heard people talk about is when you're debugging your game and you're trying to solve an issue and you have singletons, it could be anywhere in the game that is referencing that singleton, and it can be quite hard to track down what the problem is, especially when your project gets bigger and bigger and if you have more people working on it. If you're working on small games though, or prototypes, or just working by yourself, I don't really think it's a problem though. As long as you're careful, you should be able to find quite easily what references the singleton. As well, when you're making a singleton, it's important to ask, does this really need to be a singleton, and does it make sense that this will only exist once? You might be in a situation where you have a player game object and you think, this game is going to stay single player, so I'll make my player script a singleton. Now if the game stays as a single player game, perfect, no problem. But if you decide later on you want to try multiplayer, you're going to have an issue where you can't have two player scripts in your project. So you might have to refactor and change how a lot of your game works to accommodate a different type of script for your player that isn't a singleton. But then again, if you're changing a game from single player to multiplayer, you're going to have a lot of code that you probably need to redo anyway, so maybe it's not as big an issue as it sounds. So now I've explained what they are, when you use them, and some of the issues with them, I'll jump into Unity and I'll actually code a singleton to show you what they look like, and then I'll take you through the singleton script that I've written. I think I'm a little bit ill at the moment and my voice kind of keeps going in and out, so if my voice sounds weird in this video, apologies in advance. Let's go. Okay, so I'm here in Unity and I've just made a brand new project to show you from scratch how this works. So I'm going to create a 3D object, a cube, there it is in our scene. I'm going to make an empty object. I'll call this Game Manager, and then on this Game Manager I'll make a new script that I will call Game Manager. Now because we're only going to have one Game Manager in our scene and in our game, we can make this into a singleton. So now that it's compiled, I'll just right click that and click Edit Script. Cool. So let's delete this code that comes by default, and then the way we're going to do a singleton is we're going to do a public static, and then we're going to do a game manager instance. So what this means is instance is the name of this variable, and the variable type is game manager, which is going to be static. And what static means is all game manager scripts share this same variable. So if you set this instance to be something, it will be the same in any game manager scripts that you have in your project. So if, for example, you had a public static float called potato, if I set that float to 2 in one game manager script, it will be 2 in every game manager script because it's static, which means it's shared across all of those scripts. So since we know how a static variable works, we can imagine that if we have a game manager static in Game Manager, we now have an instance reference within the class itself. So the other thing we probably want to do is capitalize this because it's a public variable. And then the next part of making it a singleton is we want to do public awake, void because we don't return anything from this method, and awake is a Unity method, and Unity will call this when this game object is first used in the scene. So when this scene loads up, awake will be called, and then whatever we put in here will happen automatically within this scene. So what we want to do is if instance equals null, that means that this hasn't been set yet by any other game manager. And if that's the case, what we want to do is instance equals this. And what that will do is that this instance of game manager will set itself to be the static game manager, which means in all other game manager scripts, if there are others, this will be the one that they reference. So then what we can do is else destroy this. And what that means is if there are two game managers in your scene, the first one will check if there's an instance. If there's not an instance, it sets itself to be the instance. And if there is another one, then it destroys itself, which means no matter how many game managers you put in your script, there can only be one of them. And that's what makes this a singleton. So let's save this now. And let's go into Unity again. So now we're in Unity and we have our game manager on this game manager object. What we can do now is go to our cube, and if we add another game manager onto this object, game manager, and press play, one of those two game managers will get deleted. This game manager script has gone, and this one still exists. So it's a singleton, which means it can only exist in your scene once, and any other copies of it will get deleted. So let's delete this now so that it is only in our scene once on this script, and we'll go on our cube and we'll add a new script which we'll call player manager. We'll just wait for this to compile, and then we'll right click it and we'll click edit script. So in this script, what we can do is delete all that. We'll just do a start function. So private void start. Start is also called by Unity, but it's called after the awake functions. So if we go here in our awake function and we put a debug.log, and we'll put here game manager awake method. Cool. And then we'll add another function in here called public void method 1. And then in here we'll do debug.log method 1 has been called. Cool. And then now if we go to our player manager, what we can do is we can do a debug.log, and we'll just call this start on play manager, and then we will call game manager, and you capitalize it because you're referencing the actual script itself, and then we do dot, and then we can do instance. We can reference the actual specific game manager that is within our scene, and then we can do dot and then method 1, and we can call the method from our game manager script directly on our player manager without needing a reference to it because we've used this singleton pattern. So now if I go back to Unity, let this load, press play, you'll see that game manager awake method is being called, then start on player manager is being called, and then method 1 is being called. And you can see here that in the start function of the player manager, we call method 1 in game manager, which means without a direct reference, we were able to reference the one game manager within our scene by using a singleton. If I jump back into here now, usually if you don't use a singleton, you'd probably have to do something like serialized field, game manager, and then call it game manager like that. And then in start, you could do game manager dot method 1 like that. And then if you go back into Unity, you would then have a reference on this script here where you then need to drag in your game manager script onto that component so that it's linked up. And then if I press play, you'll see method 1 gets called twice, once through the singleton and then once through this reference that we've made here. And then another way that you could do it is, if I go back to our script, you could have a private game manager reference 2. You could do game manager reference 2 equals, then you could do find any object by type game manager, and then that will search your whole scene to try and find one. And then you can do game manager reference 2 dot method 1. Now this is fine for doing it once, but that uses more processing power than these do, because these are set automatically by themselves. So this one, you set it in Unity in the inspector, and this one is set by the singleton, and so it's set by itself, which means you don't have to do this expensive find any object by type function. And the other thing is, if you have loads of different player managers or loads of different scripts and they all need a reference to game manager, you would have to do either this or you'd have to drag it into the inspector or find another way to reference it within the scene. Or if you're just using a singleton, all you need to do is this one line where you do game manager instance.method 1. So obviously you can see why this is powerful. So one thing you might also see in a singleton is you might see something like this where it says don't destroy on load game object. And that means that when we change levels, we'll keep this game object in the scene. Well, it sort of goes into a special scene called don't destroy on load. And I can show you this by doing a public void update input.getKey down keycode.t, choosing at random, and then we do scene manager dot load scene, and we will load scene 0, which should be this scene. So to demonstrate this so you can see it, I'm actually going to turn this off. So any other game managers that are created won't be destroyed. So we should see now, when we press play, our game manager that becomes our singleton is kept in a special don't destroy on load scene. Yep, so it moves down here into this don't destroy on load. And then if I press T again, it will reload the scene and we'll have another game manager because the scene has one in. And this one won't be the instance. This one will still be our instance that is the singleton. So now I'm going to delete this bit so that when we do load the level again, we destroy the second one that we create, because there is already a singleton set as the instance. So if I press play, you should see it moves the game manager into the don't destroy on load scene. And then if I press T again, it will just reload. And it should have, oh, it has. It's destroyed the game manager script, but it hasn't destroyed the game manager game object. So that's probably what you'd want to do. So if I go back to the script again, you would probably just want to do game object here to destroy the actual game object that the singleton is on, rather than just destroy the component. Awesome. So now that I've shown you this, I'm going to show you the singleton script that I've been working on that I'm going to share with you so that you can use it, if you like, in your own projects as well. So before I run through line by line what this script does, I'll show you how easy it is to use. So if we go back to our game manager script, so to make this into a singleton using the singleton script that I've written, we would just write here using 024 for Oliver age 24, and then we're able to just delete this mono behavior and we just write singleton, and then you have to declare what type of script it is. So we'd put in their game manager, and then you get a red squiggly line, and that's because we now need to implement after on destroy and after awake. So we right click that, we click quick actions and refactorings, and then we would just click implement abstract class, and then we can delete that bit and delete that bit. And basically we use the awake function as part of this singleton, and we use the on destroy function as part of this singleton. So when they've done the things that they need to do, they'll just call this for you, the after awake, and they'll call the after on destroy. So instead of writing awake in your script, if you want to use awake, you would just use this after awake instead. And if you want to use on destroy, you would just use this on after on destroy instead. And this is all you need to do, and this now is a singleton. And so if I save this and go back to Unity, what this also will add is on your game manager script, when it loads, we've got an error because we deleted the method one from game manager, so I'll just delete that as well, and I'll just delete those while we're here and save. So we go back to Unity, and the singleton script I've written will give you this checkbox where it says persist across scenes. So if you tick this, it will do the don't destroy on load, and if you try and load the same scene, it will automatically just handle that and it'll delete any future ones you create. Or you can untick that and it will just get destroyed as normal when you load another scene. So if you load the same scene, it will just destroy itself, handle that, and then a new one will be created. So now if I jump into the script, I can run through how it works. You just write the singleton game manager instead of mono behavior, and then you have to use using 024. So if we jump into the script, you'll see namespace 024, and that's what this bit means, using 024. It just means when you write singleton, you are using the singleton from the 024 namespace. So we jump in. Basically, it's a public abstract class, and that means that you can't use it by itself. It has to be inherited by another class, which is what we're doing when we write it here. So normally you would inherit from mono behavior, but we're inheriting from singleton. And then this is in the triangular bracket things, because here it says singleton, and then in brackets we have a T, and T is called a generic, which means T can be any different type of object. So because we don't know what, I don't know what you're going to use this for, or I don't know what I'm going to use it for, I can use T, and then you just type in here what it is. And this singleton will then know whenever it sees a T, it will just replace T with what you have changed it to. And then in here as well, I have mono behavior. So this inherits from mono behavior, which is why on your script, you don't also have to inherit from mono behavior. You can just delete mono behavior and inherit from the singleton, because this inherits from mono behavior for you. And then it just says mono behavior where T is a mono behavior. So this will now be basically a mono behavior, and you can put game manager onto your objects in your scene. Cool. So that's what the first line means. And then we have header singleton settings. So when you do this header, that's what you see here, where there's like a singleton settings that appears on your script, on your object that you've made. And then you'll see a checkbox for persist across scenes, which is here. It's a protected bool, persist across scenes. And by default, I have it as false, because really you want to be aware that you are setting that to true, because it introduces quite specific behavior that you might not want. And the reason I don't like to really use the don't destroy on load is because you might create things in your scene that you only want to exist in that one scene. And if you put don't destroy on load and you load into another scene, you have to manually take care of destroying that thing. You can't rely on Unity to destroy it when a scene is loaded. Obviously, because do not destroy on load means it will always exist until you decide you don't need it anymore. So next we have a private static T instance. And this is private, which means you can only access it from this script, but it's static because it is a singleton. So it's a singleton that can only be accessed from within this script. And then we have a public static T, also called instance, but with a capital I. So this one can now be accessed from other scripts, but we only have a get function, which means you can set it within this script using this lowercase I, but you cannot set this global public one from other scripts because it is a public static and it only has a get function. It doesn't have a set function. So it will do the same code we did before. We'll check if the lowercase I instance is null. And if it is null, then we will try to find the first object by type of this within the scene. So the reason we're actually using this object find first object is because this is actually a catch-all solution to the problem where what if you call the instance before it does its awake? So if in another script you do an awake function and you reference this instance, it won't be set to anything. So that's why we do a check to see, is it set to anything? And if not, let's do this. It's called lazy initialization, where we search for the object to make it the instance manually ourselves here just to catch it. And that, I think that's called a race condition, where one script is firing before the other script is ready. So we're basically solving a problem that we might not have, because ideally people don't use awake to set up things on other scripts. They do setting up things on their own scripts in awake, and then in start, that's where you would interact with other scripts. So if that happens and it then can't find an object in the scene, it will log an error which will say no instance of, and it'll say the type of T. So in this case, it would be game manager found within the scene. And I've colored that red as well, so it stands out. And the reason I've logged it as an error is because if that happens, really it's something you should fix during development, because it would totally break the game. So for me, I want that to be an error. I want it to be obvious and I want to fix it. I don't want the game to continue as if nothing has broken, because in this situation, everything would be broken and I would want to solve that problem. And then I return null if that is the case, because I can't get one. Otherwise, I return the instance. So any other script can get the instance by doing this, and if it's not set, it will try to find one in the scene. Next, we have our awake, and this is protected and virtual because we don't want, well, I don't want you and I don't want myself to do an awake in the game manager script. Because if I do an awake here, like private awake, it will basically override the awake from the singleton that I've written here, which we don't want to happen because we definitely want this code to run for this to be a singleton. And in that case, it does a warning and it says awake is called when the script instance is being loaded, which is true, but it says that game manager awake hides the inherited member singleton awake. To make the current member override that implementation, add the override keyword, otherwise add the new keyword. And we don't want to do that, so that's why we have this after awake. So awake will get called on the singleton, and then right at the end of this awake, it will call after awake here, which is a protected abstract method, which means it has to be implemented by whatever inherits from Singleton, which is a lot of complicated words, but it basically means you have to have these two methods in your Singleton that inherits from the Singleton script. So because you have to have these two methods, we know we can call after awake after the awake function has been carried out. And the reason I've made them necessary to implement is just so you can see what you need to use when you inherit from the Singleton class. So that should make it really obvious each time you do a Singleton. Oh, I have to use the after awake function and I have to use the after on destroy function. So going back to the script, we do if the instance doesn't equal null, that means an instance has already been set. We check, does the instance equal this? Because if this other race function got carried out, the instance could already be set on our one instance of the script. And in that case, the same thing should happen. And we can put here duplicate Singleton detected, destroying the game object name. So if there is an instance and it's not this, destroy it. If it is this, actually, that's fine. If the instance is null, that's fine, continue. And if the instance is this, that's fine as well. But if it's not this and it's not null, then that is an issue. We want to destroy this and we will log an error. And for me, I consider that an error because it's a Singleton. I really want to make sure there's only one of them and I want to fix it in development rather than find out about it later or not notice that there's an issue. If it is null or it is this, we continue and we set instance to this as a T, which is whatever type it's supposed to be. And then we check if the persistent across scenes checkbox is ticked, then we want to unparent this object because do not destroy on load only works on a root object in the scene. If you have this script as a child of the other object and you do don't destroy on load and then you destroy the parent object, you will still destroy this object. So what we do there is we make sure that this Singleton is a root object within your scene. And then we log a warning that it has been unparented because it shouldn't be parented. And that as well, it's not an error because that is not crucial, but it's a warning because in development you can then fix that and have anything that's supposed to persist across scenes be a root object within the scene. So we set the parent to null if it already had a different parent that wasn't null. And then we call don't destroy on load game object, which is the game object that this Singleton is attached to. Then we call the after awake function, which just calls the after awake function on whatever has inherited this Singleton class. And then if I scroll down, we have our protected abstract void after awake, which is why you have to put it into there. And then we have the same for after on destroy. And then on destroy, we use in the same way that we use awake. So it is a protected void on destroy. And then we just do if the instance is equal to this, then the instance is equal to null. And basically, that means if we're not doing destroy on load, when we load a different scene, this will get destroyed. And on destroy, we want to make sure that this static variable is changed back to null so that the next one can be registered again as the Singleton. And I can't remember what this is called. I think it's called like a ghost reference because you have a reference to an object that you have already destroyed or deleted and you're trying to reference it even though it's been destroyed when really you want to reset it to null so that it can be set again to something else. And yeah, that takes you through this script. It's not very long, it's probably not that complicated, but this is the first time I'm sharing some code I've written for other people to use. So if you find it useful and you think this is quite a handy way to write a Singleton without having to write it every time, feel free to click in the description below, download this script, have a play about with it, and if you have any feedback on it or you make any changes that you think improve it, do let me know in the comments, because that would be awesome, so I can update it for everyone else who downloads it in future. And I think that's it for this video. So if you liked it, hit subscribe, hit like, and leave a comment letting me know what you think of Singletons, if this video made sense, if you want more videos like this, and yeah, I'll see you in the next one. Thanks for watching. Goodbye.